Not bouncing around. Check, check, check. Hello. Now it is. Welcome back, physics fans. We're going to do this question number 9 from the acceleration worksheet here. A rock is thrown 30 meters high. How long does it take to be caught at the same level? So it's thrown, it goes all the way up, it stops, and then it starts coming right back down and caught. So there's two parts to this, or we can try to look at it as one large motion, okay? At the top, we know the velocity here is 0. We don't know how fast it's thrown, and we don't know the speed that it lands at. We know that the acceleration is 9.8 meters per second squared down. We don't know the height that it went up, which is also the height that it went down. We don't know this. We don't know those. So there's a lot of stuff that we don't know. So if we don't include this zero, it's going to be very hard to solve this problem. Okay? Because we're asking for the time and we don't know VI, D, or VF. We don't know three things. Okay? So those 5 kinematic properties: acceleration, final velocity, initial velocity, displacement, and time. And we know 9.8, and that's down. So it's not good to look at the whole scene. We can't, because there's not enough information. So we're going to look at, sorry, we know the height. Sorry, my bad, 30. So this is 30 down, and this is also 30 up. But it still doesn't give us enough information. In fact, we only have 2 pieces. And if you're mathematically aware, all our formulas have 4 variables. That means we have to have 3 to calculate the 4th. And we don't have 3. So we have to include this initial speed. So we have to either look at it as the going up part or analyze the going down part. In other words, we make this VI at the top 0. Is that going to be VI is equal to 0 or VF is equal to 0? Do we want to do it that it ends there, so we get this, or begins there and use that one? I kind of like initial speed being 0 because every formula has VI in it, so it really helps and simplifies the question. So I'm only going to look at the second part of the whole motion. So let's see if I can type that in. Only look at the second part of the motion. And then once we've got the second part of the motion, then we'll be able to get the first, and therefore the whole. So the second part of the motion, it's going down at 30. And the initial speed is 0. So we can get VF and the time. The time would require that we don't use the VF formula, and that's pretty easy. We get the D equals VIT plus 1/2 AT squared. That doesn't have VF in it, and the VI is 0, so this whole term is gone because VI is 0. So solving for time with D equals 1/2 AT squared, we get T is equal to the square root of 2D over A. Just rearranging that formula, and that's going to be the square root of 2 times 30 divided by 9.8. And Mr. Calculator will help us on this one. We will go the square root of 2 times 30 divided by 9.8, and that gives us the time for the flight as 2.474. 2.474 seconds. Okay, and that will also be the same time for it to go up. So this first part will also be the time, same. First part will also be, the time will also equal 2.474. So we just have to multiply that by 2, and the time total will be 4.949 seconds. Okay, let's just draw a box a better way here. And there's other pieces of information we can get that we don't are not even asked for, but let's just quickly do it. What speed did I throw it at and what speed did it land at? They will be equal. Okay, and I can just quickly prove that because when it catches at the same location, this is up and down together, we're going to use VF squared is equal to VI squared plus 2AD, and up and down together, a displacement is 0. So this term is 0. So that means VI squared has to equal VF squared. That means one could be the negative of the other because they will have to be equal in magnitude, just opposite in direction. So there's kind of the proof that they're going to be the same magnitude. So the velocity, how fast does an object travel at after falling for a time of 2.47? We can do it that way. Or after falling from rest, this is up and down, but I'm just going to do the second part. VF squared is equal to VI squared plus 2AD. So VF is going to equal the square root of 2AD because when it's dropped, the second part, the VI is 0. So this is going to be the square root of 2 times 9.8 times 30. And that is equal to the square root of 2 times 9.8 times 30. That's the speed, 24.25. 24.25 meters per second down. And that'll be the speed that it lands at, and that'll also be the speed that it was thrown at. So we've really scienced the snot out of this and got it all done. We know all the unknowns now, and we have the total time of the trip that it asked for. Thank you very much. Enjoy.